All right, so in this video, guys, is the second one on environmental science. We're going to talk about water resources and a little bit about, and we'll move into talking about soil. So the first thing that we need to cover is potable water. Potable water refers to drinkable water. It's free from harmful chemicals and organisms. It is safe to drink. Understand that Earth's surface is covered with water. About 97% of the Earth's surface water is salt water. Only 3% of the water on Earth is fresh water, and only a fraction of that is actually safe to drink, considering it to be potable water. So it is a valuable resource, and without it, humans would not be able to survive. Water is considered a universal solvent. Basically, what this means is it's going to dissolve other materials. So any runoff, any pollutants that go into the water, it essentially will dissolve those, and it will become a part of that water. So then that's going to go into your drinking water supply, and it's going to affect, the water quality that you will consume. So the water cycle. You must understand how the water works, how it goes up into the atmosphere through evaporation. It's changing water from a liquid to a gas, so be stored in clouds, and then it precipitates back to the ground through a process called precipitation. This is moisture in the clouds, and it falls back down to earth in the form of rain or snow. And so that is how the water cycle works. We'll visualize a diagram in a minute. There's the watershed. Also in the water cycle, any water collected on Earth's surface, the surface is going to act like a bowl, and that water is going to run to the middle of that bowl. And so then you have anywhere water drains to, it's going to collect back into the rivers and ultimately going to go back into the ocean. The watershed also acts as a sponge, and it absorbs excess water into the ground. And I'll show you a diagram of that in a minute. There's also the water table. The groundwater, the water table makes up the groundwater. It's the level by which below the soil that is saturated or filled with water. So as you can see right here, it's a simple diagram to show you how the water cycle works. The sun is going to allow the water to be evaporated into the clouds. The cloud's going to hold that water in the form of water vapors in a gaseous state, and then it's going to release it as a liquid through precipitation. It's going to rain back down to earth, and it's going to fall either in the ocean or it's going to fall into the land, and ultimately the water is going to run through a river, and then most of it could either go into the groundwater or back into the ocean. So types of groundwater. There's three different types that you must understand. There's capillary. Capillary is water that is held or is available for plant roots to absorb, and so plant roots can absorb capillary water. There's free or gravitational water. Gravitational water drains out of the soil that has been wetted, and so it is freely moving. So think free, gravitational, and moves with gravity and moves through the soil. And then there's hygroscopic. Hygroscopic water is held tightly and for plant roots to absorb. And so understand that hygroscopic water is held too tightly and plant roots cannot absorb that water. So then there's ground. This shows you how the groundwater works. If you have a well or a pump, you can see in the middle of the screen right here, it's going to tap into that groundwater system, and water is either going to move along the slope of the land into nearby streams or water bodies, or it's going to move down into the land into the water table. The water table is usually higher as you get to the coast. So if you're at the North Carolina coast and you dig through the sand, eventually you're going to hit water. Or sooner than you would if you were to dig, in Raleigh. The groundwater is going to be much deeper into the ground. And so that's kind of, your well is going to tap into that groundwater, and that's where you're going to get that fresh water from. So we've seen how water is a universal solvent, and we see how how important water is to us because there's not a lot of fresh water left on Earth. And so it is important to conserve water, and we got to improve water quality. But we must ask the right questions in order to do that. So the questions that we need to answer, or we need to ask ourselves as we think about water quality, is how can we reduce water pollution? So how can we reduce the number of contaminants going into our water? How can we soil erosion be reduced? Soil erosion, as soil erodes away the top layer of soil, it moves into our lakes and streams, and that contaminates the water. Either makes it murky or decreases the water quality. And so we got to figure out how to reduce that. And then what is the most productive use of water and soil without polluting or losing these essential resources? So how do we keep our soil and how do we keep our water, and how do we use them productively? Agriculture is the #1 consumer of water in the world. Millions of gallons a year are used on small acreage plots, whether it's through rain or through irrigation systems. And so how do we make sure we're irrigating our crops so we can eat, but using water wisely? And so these are valuable questions we must answer, especially if we want future generations to be able to live on this planet. So some good practices and some things for you to think about in order to conserve water. You can save clean water, so turn off the faucet while you're brushing your teeth. You can dispose of household products carefully and appropriately. You should never pour paint down the drain or any type of chemical down the drain or in your sink, because that will ultimately lead back into the water supply, whether it's in the groundwater or lakes and rivers and streams. You should also care for your lawns, gardens, and farmland carefully. Talk about, plants need water, so your crops need water so you can eat, but how do we use water wisely? So you should only till your soil that will not erode excessively, and don't over fertilize. Nutrients through fertilizers that we feed plants, if you use too much, it's going to run into the water supply and then it contaminates the water supply. So these are all good practices, and there's many more out there that we should think about. So the last thing that we're going to talk about for this lesson is phytoremediation. We talked about this term before, but this diagram shows you how a tree acts as a filter through the process of phytoremediation. So as pollutants come into a stream or a wetland area or any area, an example would be the poplar tree that was used earlier. It could be planted, or any even grasses can be planted to actually remediate the environment, to heal it and fix it. And so as the water, the contaminated water is absorbed through the roots, it is then filtered through the tree, and then clean water is released through the leaves of the tree through a process called transpiration. It's essentially evaporation for plants, back into the atmosphere, and then we have clean water falling back to earth. And so that's how phytoremediation basically works. And it's an important concept that you need to understand. So next time, guys, we're going to talk about soil and conserving our soil and using that as a valuable resource. Thanks. I'll see you next time.